Esteemed listeners, esteemed viewers, in this tutorial we will clearly discuss the remaining portions of string functions and string handling exercises. In the previous two tutorials we discussed at length some of the predominantly used string functions, and in this we will conclude with the last string function which is also being used very predominantly, that is string reverse function. Then we take on to some miscellaneous problems on string handling. String reverse function has a syntax something like this: string reverse and string. Here the string that is to be reversed will be placed, and the outcome is, as you would have expected, the reversal of the string. I think this has no relatively practical significance except the fact that string reverse functions can be used in order to check whether the given string is a palindrome or not, or any other string processing exercises where string reversing of a string is important. And here we will just directly apply the string function and we will see exactly as to how it works. We have declared a variable over here, string variable of length 20 characters, and we also have a temporary string, because when the original string is reversed we are going to lose the original string, therefore it will be stored over here in this temporary string. Enter a string, we are using put as, you should notice, get as string. So whatever the string that we enter, of whatever the length, limiting to 509 characters, can be entered over here, and string copy. And anyway, this is an empty string and this is a string which contains the string that is to be reversed, therefore we will make a copy of it in order to store the original string. So string reverse, it is just putting this string as an argument for this particular function. So original string is printed for the sake of clarity, then when it is reversed we will put as str. So now by this point of time this string would have reversed, and we have run this program, and it is something like this: enter a string Jayaram Rao, original string is Jayaram Rao, when reversed you just notice how exactly it happened, and it carries no meaning at all. Anyway, the next program is, we will convert, this is a miscellaneous kind of a program. In this program we will convert uppercase letters in a string to lowercase letters, and lowercase letters into uppercase letters. Any other character which comes in a other than alphabets which comes in a string should remain unchanged. For example, the spaces, the question mark, the punctuation marks, and any special characters, they should not find any conversion, and it is not possible also. Anyway, we will see how exactly capital letters can be made small letters and small letters can be made capital letters. We have included string h, etc., and character sentence. We have taken 30 characters, sufficiently lengthier enough in order to call it as a sentence. Printf type a sentence, get a sentence. Okay, so the sentence will go, sentence is a string variable, and whatever that we enter will be stored in sentence. We will calculate the length of this sentence. The sentence before conversion we will just put it, and then now we will run the for loop. It should go starting from 0th character to the character 1 less than the last character, that is null character I++. Now if sentence I, that is the first character, 0th character, first character and second character, and whatever the characters that appear is greater than or equal to small a, and sentence of I lesser than or equal to small z. Okay, here the ASCII values will be compared. Greater than or equal to small a, that is 97, and lesser than or equal to 97 plus 26, whatever that comes. Okay, that is 125. 97 plus 26, 125, lesser than or equal to 125. Sentence I equal to sentence I, that is a small letter, whatever that appears over here in the sentence, minus 32, because capital letter and small letter, as we discussed in our previous tutorial, has a difference of 32. While capital A is 65, the small a is 97. Like this difference will be carried until z. So else if sentence of I is capital A greater than or equal to capital A, and sentence of I is less than or equal to capital Z, then we will just add 32 in order to convert the capital letters into small letters, and we will just leave the else block as it is. This will take care of any other character other than the alphabet. Now sentence after conversion, we will just place that, and here is a output. Type a sentence. A picture is worth 1000 words. Here this exclamatory mark and this 1 and 3 zeros should remain unchanged, and small letters should be converted into capital letters and capital letters into small letters. Sentence before conversion, same thing is printed. Sentence after conversion, you can see over here capital A has become small a, and picture has entirely converted into uppercase, and everything has happened nicely. Yeah. Now, this program counts the number of characters and number of words in a given sentence. Any sentence, of course, starts with a word, and words are separated by spaces, and the last word we will have hit the enter key, or we will have put the full stop. Taking this as the clue, we can just count the number of characters and number of words in a given sentence. So characters, this is the structure which can induct a sentence, and integer length, we will measure the length of that particular sentence, because we need to proceed character by character. Okay, and I, this may be a loop index, and ch for comparison, and words. Okay, ch equal to 0 to begin with, number of characters equal to 0, words equal to 1. It should have been, yeah, should have been 1, because the first character, first word, first thing will be a word. Okay, and clear screen. Enter a sentence terminated by a full stop. Get S structure. The string. The string will be typed over here, and the user will type a string, and it will be into this particular variable, and it will get stored in the memory. Length equal to string length of str. Okay, we will get the length of the string. Now, if for I equal to 0, I less than length, I plus plus. If string of I is equal to space, then words plus plus and character plus plus. Anyway, okay, for every this will be counted in the character. Else if string of I is equal to full stop, words plus plus and ch plus plus. Else ch plus plus. For any other thing, okay, if it is not a full stop, if it is a full stop, word will be counted, and full stop should also be counted as a character, and here it is a space. Okay, whenever a space is encountered, it is the completion of a word, therefore words will be increased, and this space is also a character will also be incremented. Otherwise, for any other character, it will be ch plus plus, that is character plus plus. And here we have taken an example. Enter a sentence terminated by a full stop. C is a middle level language. Number of characters equal to 29. We can literally count this. Okay, number of words equal to 6. 1, 2, 3, 4, 5, 6. 6 characters. Sorry, 6 words. This is the way. Number of characters we have printed, and this is the output. This is being executed literally in a Turbo C++ editor, and here it is. Now, this program checks whether a given string is a palindrome or not. Okay, before we write the program, in order to check the palindrome, whether a given string is a palindrome or not, it goes something like this. Let us say there are characters. Okay, words. Let us say word is a string, WORD, words. Okay, we have to find the length starting from here till here. We should not include /n, and this should be compared with this, one comparison. This should be compared with this. Therefore, if there are 5 characters, there will be 1 and 2. Only 2 comparisons would suffice. Only 2 comparisons is enough. And if there are n characters, n by 2 comparisons are enough, because it is 5 by 2. 5 by 2 is equal to 2, because it is an integer arithmetic, and the central one remains as it is. If the number of characters happens to be even in number, and even let us say madam, MADAM, madam. this is equal to this is equal to this, and central one remain as it is. So therefore when we compare the characters, okay, starting character, the last character, okay, the next character and the next character from behind, okay, the next character from the front and next character from the behind, like this we need to execute the loop only n by 2 number of times, where n is the length of the string up to not up to, actually up to the null character being not included. Okay, so taking this as the logic, we have written the program over here. Character string 30, the length is 30, length equal to 0 because we don't know what is the length. I and k are used as loop indices. Type a string, so string is entered, length is calculated, and k equal to length minus 1. So k is still here. So k equal to, if this were to be word, it is equal to 1 2 3 4 5. Okay, k will be equal to 5. Since this will start from 0, k will be equal to 4, right? Length minus 1. Now for I equal to 0, I less than length by 2, because the number of comparisons need be length of the string divided by 2. We have shown over here. Okay, it should be 5 by 2, like n by 2 if the length of the string is n. Okay, I plus plus. If string of I, okay, because we have initiated k equal to length minus 1, k is here, okay, length minus 1, and I will start from over here. So string of I equal to string of k. So I plus plus for loop will take care, and k minus minus we have to make. While k will move in this direction, I will move in this direction. The movement of I is controlled by for loop. K will be decremented so that it will come back one step behind. If string of I not equal to string of k, the very first comparison happens to be not equal, then there is no question of continuing with this. Therefore what we have done is we have come out of the program, because it will, otherwise it will lead to unnecessary comparison. Therefore we have just forcefully broken out of the program and we have come out, and before we came out we have declared, okay, if the very first character, or as a matter of fact any character comparison doesn't equal to the element in the string itself. Okay, so this is moving in the forward direction, this is coming in the backward direction. At any juncture, in any iteration, the characters from this end and this end is not equal, then it is not a palindrome. We will declare here only, and this is to be seen for a while until we give a character. Then we will come out of the program forcefully. Otherwise, if this particular situation is not at all met for all the length by 2 comparisons, then k will be minus. Okay, progressively k will be minus. So there will be one probe going in the forward direction, that is I. There is another probe which is coming in the backward direction, that is k. And if this is a success, then we will just print out percentages is a palindrome. Okay, and we will print that. And here is an output. Type a string Malayalam. Malayalam is a palindrome, because here we have used percentages is a palindrome, and there we have written. Okay, this program inputs 10 names, each of length at least 8 characters, and sorts them in alphabetical order. We will implement bubble sort. Here it is not an integer sorting, it is instead the sorting of strings, that is maybe a list of students, list of names of employees, or whatever. Here every element is a string. In case of bubble sort that we discussed in case of arrays, we did sorting for integer arrays as well as float arrays containing float element, and they will come in wholesome manner. Okay, so every element is either an integer or a float depending on the kind of an array, but here every element is a string by itself, because we are trying to sort, say, list of names. So here it comes with a different kind of a methodology. We have declared character temptant. Okay, that is, this is for a swapping. In bubble sort we need to swap. Okay, therefore this is meant for holding a string which is alphabetically inferior or alphabetically superior, depending on whether we are arranging the strings in a dictionary fashion or in a reversal fashion. Okay, name 10 and comma 10. This will signify list of strings, and we can hold 10 strings over here, and each of length is 10. Okay, this will represent how many. The first dimension represents how many strings can be held, okay, in that particular list, and here the maximum length of a string. Okay, therefore it cannot be taken as a two-dimensional matrix. There is no concept as far as strings are concerned. Okay, the first dimension represents how many strings, okay, how many names, and the second one represents what is the maximum length that can be permitted. As far as this example is concerned, this example can hold 10 strings, and the biggest string could be 10 characters wide. Okay, and we will use this for learning two for loops. You may recall, our esteemed viewers may recall how exactly bubble sort works. It has two for loops, one to generate iteration, the other one to generate passes. Therefore we need two loop indices. Enter 10 names. Here you have to see how exactly it works. I equal to 0, I less than or equal to 9. You could have said I equal to 0, I less than 10. That will also hold good. I plus plus. You will read the names. Okay, scanf percentages name. Okay, and if the names happens to be broken, consisting of two words, then we should have taken every name by getS. GetS name of I. Okay, name of 0, the first name of 1, the second name of 2, the third name. Okay, it's actually pointers. Okay, we will discuss all these things threadbare when we discuss pointers, but till then name of I means the first string, okay, which is in the location of 0, the second string, third string, something like this. Okay, now sorting will take place. For I equal to 0, I less than 10, that is because it should be n minus 1, we have written less than 10, I plus plus. Okay, for j equal to 0, j less than 10 minus I, j plus plus. Okay, now if string comparison name of j minus 1 comma name of j is greater than 0, that is the previous string is alphabetically superior to the next string. Alphabetically superior means if this is the largest string, getting the integer value greater than the next string, then they should be swapped. Okay, it is a dictionary kind of arrangement. Okay, JAYARAM, if that is the string, and next string is JOYRAM, there is no question of sorting. If the previous string is JOYRAM, then JA, okay, here JO, O will be compared with A, and we will get the positive difference in the ASCII values. Therefore, when the previous string is alphabetically superior, let us say alphabetically superior, and the next one is alphabetically inferior, it's going to give us positive value greater than 0. So in such case it should be sorted. It is something like sorting an integer array. The previous element cannot be more than the next element if you are arranging in ascending order. If it is more than the previous element is more than the next element, it requires swapping. And here we said array of j, temp equal to array of j plus 1 and array of j plus 1 equal to something like that. But here we can't do that. String copy temporary variable, here it will go name of j minus 1, and name of j minus 1 will get emptied, name j will be overwritten. Okay, that is string copy we are doing. We cannot equate like integer variables. Okay, string copy in j minus 1, j comma temp. Okay, so here swapping will happen if the given input is not in the arranged in the fashion of dictionary arrangement, then swapping will surely take place. And here we have 10 names. You can see this is the biggest name, and Jagadish is also biggest name, but it it is less than or equal to, so 2 plus 2 4, 4 plus 3 7, 7 plus 2 9, 9 characters. Okay, sorted names, I equal to 0, I less than 10, I plus plus, print percentages slash n, because it has to come one below the other, name I, press any key to close. So it is arranged. Okay, so we applied bubble sort, right? This program is a very interesting program. It finds whether or not a string is present in a sentence. Okay, it is searching whether a particular string of interest or a particular pattern of interest or a particular word of interest is present in a given sentence. Okay, it's a very interesting program. Anyway, this is called as string matching or string searching. Okay, we have the original string called text. Okay, this may be a description of a thing, let us say. It is a much lengthier sentence, and we need to search a particular pattern, say dog, say fruit, a particular fruit, whether or not it is present or not. That will be definitely the length of that pattern. The pattern to be searched in this main string should be less than the length of the main string, which is called as a text. So text, if text is of n characters, then pattern should be m characters. N should be much greater than m. Then only we can appreciate the searching process. So this in every iteration, this pattern is aligned with respect to this particular text, and comparison will start from here. Okay, as far as the moment of the comparison, drawing comparison between the elements of the text and the pattern, over the text there is a probe which moves, which is I, and over this j will move. Okay, this is of length n, this is of length m. Okay, and this particular pattern can move, and if it is a first failure, if the failure happens in the very first string, very first character, then it will move one character ahead. So there again, if there is a failure of the first character matching, then it will move again. Okay, let us say if it is somewhere over here, the pattern is found, j will be moving, so j of 0 equal to some length. Okay, this is character at a particular length from the beginning. Okay, anyway, I has already moved over here. Okay, so if I plus j equal to element found in j, and if this j finds, okay, moves still here, that means matching happens. So if the elements present in the pattern, all the elements, all the characters present in this particular string matches the aligned patterns, aligned characters of the text, then it is found. Then this algorithm will return from where the pattern is available. Of course, this can move, it can move until here. Therefore, as far as the length of movement of this particular string is concerned, pattern is concerned, is n minus m. Therefore, we should start comparing beyond n minus m. Okay, I can move till here, of course, but it can move, as far as comparisons are concerned, it is n minus m plus 1 for every failure. If failure happens in the very beginning portion only, then it has to stop over there. Okay, and j will move going till here, so then in that case I can move up till this particular point. So this is the thing. Okay, so if at all pattern is found anywhere, j will have reached all the m characters. Okay, if at all pattern is not found anywhere, j will be either 0 or anything within m. Okay, this is the clue. So we will declare description, which is the text, which is lengthier than the pattern. Okay, these are all the variables that are needed. Enter the description of a thing in a sentence. Gets description. Okay, n equal to string length description. Okay, string length description. M equal to string length pattern. So in the previous stage we obtained what is the length of the text, what is the length of the big sentence or a big string. Okay, and here for I equal to 0, I less than n minus m. Okay, so here n is length of the big string and m is length of the small string which is to be searched. So I can move I equal to 0. Oh. Yeah, I equal to 0, I less than n. I think we should have made it as n. Sorry, I can move up to n because the string may be available at the end. Okay, I less than n, I plus plus, j equal to 0. So in every iteration, so I moves progressively from 0 to n. In every iteration, j equal to 0, flag equal to 0. We will assume none of the characters will match. Okay, as far as j is concerned, as far as the condition is concerned, while j is less than m, j can move up to m minus 1. Okay, because j is a pointer, j is a probe which will move on the pattern, and pattern of j equal to description of I plus j, because I has already come somewhere to the midst, so it has to continue progressively. It is not like j. Okay, I can move up to n, but number of comparisons happens to be n minus m till here. If the failure happens right in the first character, and here also one comparison will happen. So therefore, in the best case, it is n minus m plus 1 comparisons. Okay, n minus m every comparison. When it stops over here, when it stands over here, it cannot further move because the text ceases to exist, and here also one comparison should take place between the characters. Okay, this is also a failure, let us say. As far as I is concerned, I can move from here till here up to the last character. This is what we wanted to say. Okay, so while j less than m and pattern of j, okay, the aligned character of the pattern with the character of the description, that is the text, I plus j, then j equal to j plus 1, j can move. Okay, if everything happens, okay, let us say j is less than m, it has moved to the last point, and in every movement of j, this is a matching. Then at the end, if j will be equal to m, okay, all the characters of pattern matches means j will be equal to m. If j equal to m, then flag equal to 1 and break. We can come out of this for loop. Okay, there is nothing like continuing. Okay, and then we will say if flag equal to 1, the pattern percentages is found and it starts from percentage dth character. So pattern I will have moved till that particular point. So printf, the pattern percentages is not found in the pattern. So we have actually run a program. Okay, ran a program. This is the output. This is the screen snapshot. Enter the description of a thing in a sentence. The honey is sweet. Enter the string to be searched. Sweet. Okay, the pattern sweet. Okay, the pattern sweet, it has come over here. The pattern percentages. Okay, pattern is over there. Okay, I position. Okay, the pattern suite is found and it starts from 13th character. So where is it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It starts from 13. Okay, so this is found. If it is not found, the other printf statement would have printed. Okay, they enter the string to be searched sweet. So m over here is 1, 2, 3, 4, 5. Okay, m of 0, m of 1, m of 2, sorry, pattern of 0, pattern of 1, pattern of 2, pattern of 3, pattern of 4. So all of them having been matched means okay, this is the condition that has been reached. Where is it? Yeah, j equal to m. J becomes equal to m. Okay, because j would have been incremented in the previous step, right? So this completes almost all kind of problems that can be done with strings. Okay, we have closed. Okay, I think the whatever that I wanted to tell my respected viewers is over as far as string is concerned. We will revisit the string whenever we discuss pointers. Of course, strings can be handled with pointers also. We will see that. Till then, bye. And if you liked this video, kindly subscribe.